Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and in this video, we're diving deeper into inverse functions. We're going to look at how domain restrictions might come into play and how to find inverses that may require a little bit more algebra skills. So let's jump right in with this example here. We want to find the inverse function of this rational equation here. So recall that the first step to finding an inverse function is to swap your x and your y. So the f of x here, that acts as our y. So we're going to replace that with x, and then we're going to replace all the x's with y's. So that's going to be 3y plus 2 over y minus 1. And now we're going to multiply both sides by y minus 1 and then distribute it on the left side. So that means we're going to get x times y minus x is equal to 3y plus 2. Next, we're going to gather all the terms with y on one side and then all the terms without y on the opposite side. So meaning we're going to get xy minus 3y is equal to x plus 2. So the reason we want to do this is so that we can factor out the y on the left-hand side. So that's going to give us y times x minus 3 is equal to x plus 2. So now we can finally isolate our y. So which means we're going to get y is equal to x plus 2 over x minus 3. And now the final step, remember, is that you have to express your answer as the inverse function. So which means we're going to get f inverse of x is equal to x plus 2 over x minus 3. So for this next example, we're going to take a look at inverse problems that involve domain restriction. So let's consider the function g of x, which is equal to the square root of x minus 3. We're going to find the inverse, and then we're going to graph both g of x and the inverse function. So now to find the inverse function, we're going to swap our x and y like usual. So we get x is equal to the square root of y minus 3. Now we're going to square both sides to get x squared is equal to y minus 3. And then isolating y is going to give us x squared plus 3. So our inverse function is equal to x squared plus 3. So let's go ahead and graph our g of x and our g inverse of x. Okay, so we're going to do a quick graph. So original graph is the square root of x minus 3. And that is going to look something like this. So let's say here is our 3. It's going to look like this. So this here is our g of x. Next, we're going to graph our inverse function, which is x squared plus 3. And x squared plus 3 is a parabola with the vertex at 0, 3. So it'll look something like this. So if we look at these two graphs, you'll notice something interesting. Those two graphs don't appear to be reflections of each other across the line y equals x. Because recall that inverse functions are reflections of each other across this diagonal line here. So now, upon closer inspection, we can notice that our original function, g of x, almost looks like half of that inverse function. So if we think about swapping the x and y coordinates of the original function, we notice that we want to retain just the right half of the quadratic equation. So meaning we only want this half. So therefore, to write our solution for the inverse, we need to include a domain restriction on our answer. So meaning what we have here is not enough. We need to add on the domain restriction, which is x is greater than or equal to 0. So we need this whole thing, and that is our inverse function. So now let's explore that a little bit more. Suppose that we have this function here, f of x. So step 1, we're going to find the inverse. So to start, we're going to replace our y with our x and our x with our y, which means we start with x is equal to 1/2 of y squared minus 3. We're going to move the 3 over, and that gets us x plus 3 is equal to 1/2 y squared. Multiplying both sides by 2 will give us 2 times x plus 3 is equal to y squared. And then finally, we're going to take the square root of both sides. So we end up with y is equal to the square root of 2 times x plus 3. But wait, we're actually missing something here, because when we take the square root, we're going to have a positive and a negative part. So which means we actually run into a problem here, because this result is not a function due to that plus or minus sign. It would not pass the vertical line test. So let's take a look at what I mean by that. So here we have 2 parts to that equation. So we have the blue graph, which is the positive square root of 2 times x plus 3. And then we have the green graph, which is the negative root. So notice how if we only have one of them, that's only half of it. So if we look at both of them combined, this is not going to pass the vertical line test, which is why the plus and minus in front of the square root makes it so that it is no longer a function. So if our inverse function doesn't pass the vertical line test, then that means our original function, which is up here, this is not going to pass the horizontal line test. So therefore, we must restrict the domain of the original function so that it passes the horizontal test. And this is what we call one-to-one. So this means we're going to go back to our original function f of x, and we're going to add a domain restriction so that it passes the horizontal line test. So here, we're going to add the restriction that x has to be greater than or equal to 0, which means we're only taking the right side of that parabola. So now, notice that if we only have the right half of the parabola, then the positive square root portion is the inverse of this red graph. Notice how there are now mirror images of each other across the line y is equal to x. And similarly, if we restrict the domain to x is less than or equal to 0, then the inverse of that is going to be the green graph, which is the negative square root part. So let's go back to our notebook and write down what I just went over. So we're going to need to break down this function into 2 parts. So the first part is if our function f of x is equal to 1/2 x squared minus 3, and we set the domain restriction to be x is greater than or equal to 0, then our inverse function, f inverse of x, is going to be the positive square root of 2 times x plus 3. Similarly, if we set our original function f of x with a domain restriction of x is less than or equal to 0, then our inverse function, f inverse of x, is going to be the negative square root of 2 times x plus 3. So basically, we're breaking down the positive and negative case into 2 inverses, depending on which side of the original function we want to work with. So now let's do a recap of what we have learned about inverse functions. So it is very important to consider the domain of the original functions and the inverse functions to ensure that we meet the criterion for being a function. And this means we need to always check if the original function is one-to-one before attempting to find an inverse. If not, we have to restrict the domain so that it is. So in other words, we must make sure that the original function passes the horizontal line test so that its inverse can pass the vertical line test. So now it's your turn to give this a try. So given the function h of x, find the inverse function and its corresponding domain restrictions. And make sure you leave your answer in the comments below and let us know if you'd like to see more content on inverses in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.